Hello friends, today we are going to see electric field produced between the two parallel plate. Okay, so it is a capacitance of capacitor or electric field produced stored between the two between the two plates. Okay, so today we are going to learn full concept for electric field produced between the two parallel plate. Okay, two parallel charged plate. Okay, so before going to learn this, you should know what is the electric field going to produced by the plane sheet. Okay, so I am taken this plane sheet. Okay, so we are going to learn how much electric field is going to produced by plane sheet. Okay, it is I am taken is a positively charged plane sheet. Okay, it is a positively charged plane sheet. So the electric field from plus it will be outwards. Okay, so the electric field will be outwards. So a lot of lines it's going to represent. Okay, electric field is pointing perpendicularly outwards. Okay, so as we know, electric flux is equal to E, it is dA cos theta. Electric flux is this much. Okay, it is a closed integral. Okay, again for Gauss law, E is equal to electric flux is equal to Q divided by epsilon naught. This two statement already we know. Okay, see here, it is from the sheet electric field is pointing outwards. Okay, today we are going to learn what is the net electric field going to produce between the two parallel plates. Before going to that, you should learn what is the electric field produced by one plane sheet. Okay, so I am taken 2 point, one point is here P, another point I am taken here, it is a P dash. Okay, 2 point I am taken. Okay, so this side I consider as one area, this side I consider as the area. Okay, so see, in this point area vector will be outwards and electric field will be outwards. What is area vector? If you consider this is a plane, okay, this is a area perpendicular line will be representing always area vector. So that means at this point area vector will be this side, electric field will be this side. Okay, so electric field is pointing outwards. So electric field and area vector angle will be 0 degree. Okay, now so I am going to find the electric flux at the point of P. Okay, so one side I am taken, so E integral of EdA cos theta. So theta will be 0 degree, cos 0 will be 1. Okay, so closed integral of EdA. Closed integral of EdA is going to represent A only. Okay, so electric field produced at the side of this side will be EA. Okay, and this side, okay, so electric field is produced at P dash is the EA. Okay, what is the net electric field produced between the between for the this plate? Okay, it is total flux is equal to flux at P point, flux at P dash. Okay, so EA plus EA, so we got 2 times of EA. So as we know, we got flux is equal to 2 times of EA. As we know Gauss law, flux is equal to, according to the Gauss law, given the law, flux, electric flux is equal to Q divided by epsilon naught. Okay, equation 1 and equation 2 is representing the same. Okay, so Q divided by epsilon naught is equal to 2EA. So we are finding what is E. So E is equal to Q divided by 2 epsilon naught A. So charge density, okay, charge density is a Q divided by A. So how much charge present per unit area, we can take it as Q divided by A. So Q divided by A, we can take it as a sigma, it's a charge density. So charge density divided by 2 epsilon naught. So I got what is the electric field produced between the for one plate. Okay, now we have two plate. Okay, so first initially I am going to take it both the plate is a plus. So plus like this. Okay, 2 plate I am taken. So I am going to consider with the 3 point. Okay, one is the inside, 2 is the outside. P Q R, P Q R. Okay, from the plate 1 I am calling it as a charge density sigma 1, plate 2 I am calling charge density is a sigma 2. Okay, from plate 1 it is plus, electric field will be outwards. Okay, so E1 it's produced outwards, E1 is produced outwards, E1 is produced outwards. From the plate to E2, E2 will be outwards, E2 will be outwards, E2 will be outwards, E2 will be outwards. So first we'll see at the point of P, at the point of P. So the net electric field at the point of P, E1 plus E2, because both is in the same direction. Okay, at the point of P, E1 plus E2 is equal to net electric field. So E1 is a sigma 1 divided by 2 epsilon naught. E2 is a sigma 2 divided by 2 epsilon naught. Both is equal, okay? Sigma 1 is equal to sigma 2. That means we'll get 2 times of sigma by 2 epsilon naught. 2 to get cancelled, sigma by epsilon naught, okay? So the next thing, it is outside, okay? What is E net at the point of Q, okay? So E1 plus E2. E1 minus E2, okay? E1 is a sigma 1 divided by 2 epsilon naught and a sigma 2 divided by 2 epsilon naught. Why I am doing subtraction here? Because both is opposite direction, okay? So this value, E net value will be 0, okay, at the center, okay, at center. So now at the point of R, okay, this side, okay, so it is also will be representing in the same direction, okay. So E net is equal to E1 plus E2. So E1 is a sigma 1 divided by 2 epsilon naught plus sigma 2 divided by 2 epsilon naught. Both is equal, so 2 times of sigma divided by 2 epsilon naught. So sigma by epsilon naught will get as a E net, okay. So next, okay, so I got as a E net, okay. If you like my channel, you please subscribe, okay. So E net I got, okay. So in case both the plate is both is plus 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 like this, center will be 0. This side will be sigma by epsilon naught, this side will be sigma by epsilon naught, okay. Now we will be going to see actually what is a parallel plate capacitor, okay. So what is energy, what is electric field stored between the two parallel plate capacitors, okay. So now I am taken both the plate, one plate is a plus, one plate is a plus, another plate is a minus. So minus, the electric field will be towards, plus the electric field will be outwards. So same P Q R, 3 point P Q R, okay. It is sigma 1, it is sigma 2. Now it is plus, it is minus, okay. From plus, E1 will be outwards, E1 will be outwards, and E1 will be outwards. Minus, okay, minus, the electric field always pointing towards, okay. So E2, it's towards, E2 towards plate 2, okay, it's towards plate 2, okay. So see here at the point E1 and E2 is the opposite. The net electric field at the point P, at the point P, the net electric field is 0, okay. At the point R, the net electric field is 0 because it's both is equal and opposite. At net electric field is equal to 0 at here, okay. What is the net electric field at center, okay. So at the point of Q, so at the point of at Q, so E1 plus E2. So sigma 1 divided by 2 epsilon naught plus sigma 2 divided by 2 epsilon naught. So we'll get 2 times of sigma divided by 2 epsilon naught, 2 to get cancelled. So E net will be sigma by epsilon naught, okay. So as we know, both is plus. So both is plus, center will be 0, this side will be sigma by epsilon naught, this side will be sigma by epsilon naught, okay. As we know, one is plus, another one is a minus, okay. From this video we conclude at the center, one is plus, one is a minus. At center, E net value will be sigma divided by epsilon naught at center, okay. So this we got, okay. So as we know, now E we got like this, okay. Relation between E, V and the distance between the two plates, okay. So E is equal to V divided by D, velocity gradient, okay. In potentiometer also we will be learning potential gradient is equal to V by L, okay. And the same thing, it is a potential gradient, okay, volt per unit length. So voltage per unit distance, we will take it as electric field, okay. So electric field now we got is sigma divided by epsilon naught is equal to V divided by D. So I got, this is the equation, okay. Now I got voltage, okay. So I'm going to teach you how to find the capacitance, okay. So capacitance of capacitor to plate, okay, capacitance of capacitor C is V is directly proportional to Q. So Q is equal to constant times of V. Constant is here capacitance of capacitor CV, okay. So now C is equal to Q divided by V. I know what is V, okay. So V is equal to it's sigma D divided by epsilon naught, okay. So V already we got, V is equal to sigma D divided by epsilon naught, okay. So Q sigma D divided by epsilon naught, D divided by epsilon naught, this is a C we got, okay. Sigma is what? Charge density. It is a Q divided by A. Charge per unit area, we can take it as a charge density, okay. So it is Q divided by sigma Q divided by A D divided by epsilon naught. Q get cancelled. Okay, the capacitance of capacitor between the two plate A epsilon naught D. The factors affecting the capacitance factor C is directly proportional to A, and C is directly proportional to nature of the material. Okay, and C is inversely proportional to distance between the two plate. Okay, so today we learned what is the electric field between the two parallel plate capacitor, and what is the capacitance of capacitor between the two parallel plate. Thank you.